total ammonia becomes more and more non-toxic. And this is important when you're shipping fish. Say you've gone to a fish show and you decided at the last minute to grab this fish, and now you've put it in a bag and you take it home, but your drive home is 8, 10, 12 hours. What's happening in that fish bag? The fish are respiring, so they're producing CO2. The CO2 is causing the pH to drop. I'm trying to talk with my hands, but you can't see that. As the pH drops, the ammonia the fish is excreting is becoming non-toxic because it's dominated by the ammonium form. You get home and you open that bag up, and what do a lot of people do is they drip acclimate. They take good high pH salt water and they're dripping that into a bag which is full of ammonium, and it's causing the pH to shift to a higher point, and that ammonium now is being converted to ammonia, and your fish becomes stressed. I used to run a hybrid striped bass farm. We raised the fingerlings in San Diego, and then we would drive them out to the farm in Mecca, California. So I've acclimated literally hundreds of thousands of fish. We never drip acclimated. I'm not a fan of drip acclimation unless temperature. I'm just not a fan of drip acclimation. If temperature is really different, float the bag. But drip acclimation, especially in a bag that's where it's been closed and you know there's a lot of ammonia in it, will shift the pH up. It'll turn the total ammonia, most of it, into the toxic form, and now your fish are being stressed. That's just my opinion and experience. Nitrification, it's a basic step. Now I've got two basic steps. Those organisms still dominate. The single one has been found in freshwater systems, hasn't been isolated from a saltwater system yet. Step one is the ammonia oxidation. It's done ammonia. The bacteria use NH3 and they use oxygen. And this is another thing, people, I think I make nitrifying bacteria and I bottle them. And a lot of people tell me every day that I'm a moron because everybody knows that bacteria can't live in a bottle because they can't breathe. Bacteria don't have lungs, so they don't breathe. Nitrifying bacteria only need to have oxygen present if they're oxidizing ammonia. So they do fine in a bottle. Why people say nitrifying bacteria don't live in a bottle is that even to this day, the vast majority of the companies selling nitrifying bacteria are selling the wrong nitrifying bacteria. I showed that, like I said, in the mid-90s doing my PhD. There's a whole institute at the University of Vienna, down in another one in Australia that keeps on studying nitrifiers. And this is pretty much proven science of what species are in aquariums in low ammonia environments. It's not Nitrous ammonius europaea and not Nitrobacter winogradsky. It's different ones. Down below here in the corner is a picture from our microscope. It's a technique called, strangely enough, FISH. And that stands for fluorescent in situ hybridization, where you can actually bind a fluorochrome to the different species of bacteria. So the ammonia oxidizers are there in green, the nitrite oxidizers are in red, and it's fuzzy because these bacteria grow in a biofilm. They do not grow as single-celled organisms. Nitrifiers are not in the water, they're on surfaces. So they convert ammonia to nitrite, and as you can see, they produce hydrogen ions, the 5H there. Then step two is nitrite oxidation, where nitrite plus some water produces nitrate plus some more hydrogen ions. And so the nitrifying process is producing hydrogen ions. And remember what we said earlier is that alkalinity is basically the resistance to producing acids. It's the TUMS. So nitrifying bacteria producing acid because we're feeding the fish produce ammonia. Nitrification produces hydrogen ions. Alkalinity consumes that. Once your alkalinity is used up, then you start seeing a pH drop because as the hydrogen ions increase, the pH value gets lower because it's a negative number. That's how you tie this together. And this process can't be stopped unless you get glass fish and don't feed your aquarium, but then it's not really an aquarium. So this is a natural part of what's happening in aquariums is you're adding hydrogen ions and your alkalinity counteracts that. So in some nitrification, ammonia is produced, hydrogen ions are produced and oxygen is consumed, alkalinity is reduced, your pH will eventually drop. Once your pH in a freshwater tank gets about 6.5, nitrification stops. Why? If you remember that chart, at about 6.5, all the ammonia is in the ammonium form, and the nitrifying bacteria don't use that form because it can't diffuse into the bacterial cell. Change the pH, and the bacteria go to work. The bacteria aren't dead. It's actually quite hard to kill nitrifiers, but they stop. They just stop working because they can't get the ammonia in the form they need. And this is a typical freshwater system. This is actually measurements in tanks we did. And that sawtooth thing, that's the pH going up and down as the alkalinity is being consumed. And this is very typical in freshwater and in saltwater systems where people don't do changes. People pride themselves, well, I've never changed my water. But then they try to add a new fish and that fish dies because it's not acclimatized to the poor water quality conditions that are in that aquarium. Phosphate is another one. So the only form of phosphate that can be used is PO43- or what's called soluble reactive phosphate. But studies have shown that that's only about 2% of the total phosphate in your aquarium. Phosphate sticks to organics, it can stick to rocks, it likes to bind with calcium, and the buildup of phosphate can promote algae growth. That's a talk I was giving last weekend of cynos, dinos, and algae oh my to public aquariums because they have the same issue of fighting cynos and dinos. And their issue is that the public wants gin clear water, and they use lots of mechanical methods to make that water so clear that it's basically sterile. Mainly comes from the food, and also frozen foods can use phosphate as a preservative. That's why you should rinse your food. But you have to have phosphate in food. Phosphate's like octane in gasoline. If there's no phosphate in your quote fish food, that's basically cardboard. You have to have it. So the water chemistry basics, I mean, that's the basics of this. I know this is kind of can be a dry subject. In part two, I talk about test kits because those are misused. And then part three, I go pretty deep into reef tank water chemistry, but I didn't want to start right there. I wanted to kind of set the table, and then I can get invited back, hopefully, and go deep into this. And as I know, chemistry is not everyone's favorite subject.
Yes, you're invited.
So, and now I can take questions if you'd like.
We have a question from Seth. He's saying, so you don't believe in ICP test nitrate readings at all?
No, it can't measure nitrate. It
What do
takes
you
that.
think about the OCEAMA though, the new test that they have, MS?
It can't measure nitrate, period. I don't care what anybody says, and I'll debate them. You can go to the manufacturer. What happens, any nitrate that is in the water, once the the sample goes into the plasma, the nitrogen, the N, nitrate, NO, nitrogen and oxygen, they're broken off. They're broken apart. And the oxygen is vaporized. ICP can't measure oxygen. It just doesn't. If I go back, let's see, did I put, yeah. See, I'm not sharing my screen. Sorry about that.
But the
Are you
idea
good?
is that basically, if you're looking at ammonia or you're looking at nitrate, when that vaporization happens, it's a different point in the process. You can tell at what point that vaporization happens. That's what the test is watching for. So,
No, that's not what the test is doing. No,
Did you put more or same amount? I just need to know how much to judge.
what's that? The vaporization happens, then it goes to the detector. So you can't distinguish whether where the end came from, where the hydrogen came from, which it doesn't even measure hydrogen very well, and it doesn't measure oxygen. So you can't measure nitrate. You can't measure any compounds with an ICP test.
What do you prefer test for the nitrate and phosphate for salt water?
For salt water, well, I mean, we do sell a test kit. The Hunted is okay. All these test kits available to hobbyists are indicators.
Okay-ish. Yes.
They're indicators. One, there's no standardization. There's nobody when in our lab, the first thing we do is we have known standards and we run a test, and you make sure your standards are working, and you set up your curve, and then you test knowns to see how it goes. And none of the ICP, none of these companies do that. And that's why, there was this, like 2 or 3 years ago, one of the companies was reporting people had mercury in their aquariums. I've got the test results. I was being flooded with people. What do I do? And the amount of mercury they were reporting would be an EPA hazardous site, because there's no quality control with any of these companies. And I don't sell IPT testing, but I used to run a testing lab, and they don't do any of this. The other thing, now one company has started to do that, is you don't pre-sample your water. I said it was biological. So what do? You collect water. Well, any algae, any bacteria, any viruses, any organisms that were in that sample, when that sample goes through the ICP part, the plasma part, their body is being vaporized and goes in any nitrogen, phosphate, anything they had is now part of that test. You don't know whether it was in the water or it came from organisms. The first thing any analytical lab, if you're going to be doing testing, and I've done this both in lakes and in oceans, off of ships, is you're pre-filtering your water to get rid of biological samples. You're interested in what the water chemistry is, not the water chemistry with a bunch of organisms vaporized in it. Nobody sends you, I think one company I started doing,
Ociyama. The little
sent you a sample to
filter.
filter out any biological substances. Secondly, so now you've got your sample, it's got bacteria in there, and now you've got transit time. The bacteria, as I said, they don't care whether there's oxygen, low oxygen, or no oxygen in the water. They're going to keep on working. And so now they're changing the water chemistry in transit. There's no preservatives, there's no filtration. It's not how a lab's going to work. And yet you're trying to you believe these results that are supposedly down into, parts per billion or less. And then that's the other part, is you can go to the manuals of these equipment manufacturers, and you can see that they'll tell you that the minimal detectable limit is much higher than what these companies are reporting. So
So Destiny had a little question. She was asking, so in regards to ICP, do you recommend not using it at all, or what is the ICP useful for? When would you use the ICP?
ICP would be best used for if you think you have like heavy metal contamination. If you're measuring phosphates, nitrates, compounds like that, ICP is a waste. If you think that you have heavy metal, chromium, lead, things like that, then that's what ICP can definitely be used for.
We have another question. Do you want to ask? Going back to go ahead.
So ICP tests are useful for the things that you can't test for, but if there's a hobby grade test that you can test for, you're probably better off with the hobby grade test.
Yes, exactly.
I agree.
Yeah. And also, ICP is kind of like, now everybody's doing bionomics testing. It's only a shot at one time. It's better to get a trend to know where your aquarium's going, to see then if something happens, oh, this went really high or this went really low. Like, prime example, people in Southern California some do tend to go get water right off the ocean. And in San Diego, where I went to school and grew up, you could go down to Scripps and they had filtered seawater. Well, now, unfortunately, in the LA area, with all the fires, that we've had and the winds, there's a lot of the wind blows offshore, and you've got a lot of pollution now in the near, the pool, where you can go, the ocean right off the coast, and you don't want to be using that water. Most nearshore waters where there's big population centers are really high in aluminum, in chromium, and different things like that. So you want to be careful about using natural seawater.
So we have a question from Christiana. Going back to the anaerobic topic, what is your opinion about the old-fashioned dip sand bed tanks?
Deep
And
sand bed,
and reverse, yeah, and the gravel
reverse,
filter.
well, reverse under gravel filters, I love those. We did that when I was at Marineland, because basically instead of the water going down through the under gravel and trapping all that organics, you had the water being filtered through sponges, and then clean water was going up through the gravel. And they're great, except they didn't agitate the water surface. And most of your oxygen exchange is not happening from bubbles. It's happening from the commotion, the disturbance of the water surface. Jobert tanks, deep sand tanks, are basically ticking time bombs. Invariably, you're going to stir that up, and that water that's in the plenum. So if you don't know Jobert tank, there was usually a false bottom. So there was a layer at the very bottom that had water, and then you had a screen, and then you covered it pretty deep with maybe 4 inches of substrate. And you were trying to promote an anaerobic zone to have denitrification. The problem with that, and this happens, I work with all the major aquariums because they're trying to reduce their nitrate levels, is that it's really hard to keep it anaerobic and not going anoxic. And once the system goes anoxic, the hydrogen sulfate production is crazy. And then that starts killing everything. So I not so much now, but for years, every time I went to a wrap, a Reefapalooza, someone would come up to me and say, I wiped out my entire tank. And what did you do? Well, I had this thick gravel and I stirred it up. And you release that, and it just kills everything within hours.
Seth had a question. If you're going to start dry rock today, what bacteria would you start with?
Well, I grow bacteria, so I would start with a combination. I would start with my nitrifying bacteria and then follow it up with our waste away bacteria. During startup, I don't like adding heterotrophic bacteria because heterotrophs compete for the micronutrients that the nitrifiers need. and nitrifying bacteria are very slow growing. So you don't want to get them established first. I have a talk I did that at MACNA, and it's on YouTube about how to set up your tank for in the beginning for nitrifiers and then adding fish. Then I can see a question about how does copper affect nitrifiers? And nitrifiers are interesting because their cytochrome has actually got copper in it. So copper doesn't actually kill nitrifiers. It can slow their growth at high, therapeutic levels. But at low levels of copper, nitrifiers actually do fine because of their physiology, which I won't go deep into, but they definitely can tolerate copper. Also, because they grow in the biofilms, that's one thing about nitrifiers is they're pretty resistant to many of the treatments that we give because they're growing in a biofilm, which is basically a force field that consumes a lot of that material.
When is it too late to remove sand from a dip sand bed?
Well, um, to do that, you have to make sure you have a lot of, well, what I would do is have a whole nother tank, and I would move my fish to another tank and just do the whole thing in one fell swoop. It's just very hard because once you disturb that, you're going to release the hydrogen sulfide. And one way you can tell, and I was at a public aquarium system when we were looking at this, if you're looking at the side of the glass and the bottom part is black, or you can see in your substrate, you're starting to get black coming up, that is a sure sign of hydrogen sulfide.
So would you recommend like disturbing your sand every once in a while and remove some of the compounds from it? Like when you do a water change, clean your sand.
Yes, I recommend gravel, not a lot, but on a regular basis, cleaning whatever substrate or sand you have, or keep it very thin because
Yeah, that's what I have.
yeah, it'll build up. I'm
I
not a
do
fan
have,
of anything over about an inch unless you're going to
I,
maintain it or keep sand sifters in there, something that turns it up.
oh yeah, like grasses and yep.
Yeah,
I do have a question. You mentioned about do not drip acclimate your fish.
in my opinion. Yeah.
Yeah. So just because of the possible of the ammonia and
Yeah, and
te-
I gave a talk like this to the people at Seagrest, and they don't trip acclimate. Was I was told they do the dump method just because it's mostly doing with ammonia. I mean,
yeah.
you get fish in a long period of time, and there's a lot of ammonia in the tank, but the pH is low. I did my master's degree in ammonia toxicity in fish,
Mm.
so we could have the same level of ammonia, the same fish, but it was all dependent upon pH of the water, of how toxic, or even if the ammonia was toxic. It has to do with pH. So I see someone, you're starting a
Diane,
5-gallon tank, live sand, coated live
mariculture,
rock,
live rock.
and should I add additional liquid bacteria? Um, well, it all depends upon the live sand because most of that live sand doesn't have nitrifying bacteria in it, and it usually prolongs the cycle. I get a lot of people that say, "Well, my system's not working," and what did you use? Live sand, and the live sand um, is full of organics and bacteria that are robbing the micronutrients, and they slow the nitrifiers from reproducing. Uh, Usually live sand means your cycle's going to take longer. It just my experience talking to, I talk to people all the time and do all the shows, the aquashellas and the macnas and stuff like that.
So earlier you said that all the nitrifying bacteria is attached to a surface, correct?
Correct.
So does it benefit you to have added surface area like live rock, the sides of your aquarium wall, your sump and all, all the surfaces there. Does it benefit you to have more surface area, or is there a point where more isn't necessarily better?
There's a point where more isn't necessarily better because the bacteria only grow to the amount of ammonia being produced. You can't grow more bacteria just because there's more space. So you need to keep it clean. The biggest detriment to nitrifying bacteria is if whatever you're using for a biological filter is also a mechanical filter, so it's being clogged because the nitrifying bacteria need oxygen.